Okay, I hope you got 5x equals 9 and x equals 9/5. Is that right? Does that look okay to everybody? Okie dokie, Smokies. All right, next one. Going to solve this equation. Okay, we're going to solve this little logarithmic equation. Now, the issue with it is what? What is wrong with this equation? There's two of them there. There's two of them there. That's exactly right. Very good. You are not, I mean, you can't deal with that. So you need to fix that. Unfortunately, there's something standing in your way. You can't just smash these together until you deal with that. These leading coefficients are troublesome. Please don't say divide everything by 2, because while that is almost always what we want to do, what would happen if we divided everything by 2? Can you see? It wouldn't fix the problem. It would just move the coefficient to this. This now has a coefficient of 1/2. So instead, we have to remember that a number in front of a logarithm can be rewritten as an exponent. One of your properties of logarithms says that a number in front of a logarithm can be thought of as an exponent. So this is the log base 5 of 9, 3 squared, minus the log base 5 of x. Now we can put them together. Okay? Now, if this hadn't been here, I would absolutely divide by 2. There'd be nothing stopping me from doing that, and that would be easy. But I can't divide by 2, so I got to think of that 2 as an exponent. Now, what am I going to have inside my parentheses when I put these two logs together? What's going to go in here?
Division.
9 over x.
It's 9, I heard 9 over x, I heard division, everybody's right. 9 over 5. Or 9 over 5, 9 over x. Now what? We're not done. We said we have to figure out what x is. What do I do now?
The loop-de-loop.
The loop-de-loop thing. So 5 to the second equals 9 over x. So 9 over x equals 25. 9 equals 25x, and x equals 9/25. So the answer to that one is 9/25. Anybody have a question about that? Okie dokie. One more. These are just review problems. Log base 7, x squared y over z cubed. The directions say expand. So it's sort of the opposite of what you did right here. Right here you had 2 logarithms and you condensed it down into 1. Now you've got 1 logarithm and you're supposed to pull it apart. All right? Does anybody have a thought on what the first step might be as we start pulling this thing apart?
You're gonna like subtract.
Yep.
So
Yep.
break it apart.
Yep,
Like, x squared.
exactly. And if you want to, Jacob and everybody else, you can go ahead and have your log of x squared plus your log of y, and then minus your log of z cubed. Now, I did all that in one step, which you're certainly allowed to, but you could also split it up and do it in 2 steps if you preferred. Does everybody recognize where this plus came from? These two guys are multiplied. So when I pull it apart, it's a plus. That is a minus because this is a division. Now we're not quite done. If we want to fully and completely expand this, there's one more thing we have to do. Do you have an idea?
Do you move the exponents down and make them coefficients?
Bingo, Grace, right on target. So this becomes a coefficient. So 2 log base 7 of x, log base 7 of y, and 3 log base 7 of z. Perfectly done. Perfectly done. Okay, so that's it for today's review. I did just last period put into Power School your test date, at least what I think is going to be your test date. So you might want to keep that in mind. We will be having a test next week. Tomorrow, or whenever I see you the first time, I have a whole pile of hard copy stuff. I'm going to give you a whole bunch so that you have it, and we'll be using that for our review. Okay, now back to our notes. Let's see. We may not finish them all, but we're getting close. We are getting close. We are in section 3.6, and we're ready for problem number 6. So keep in mind we have 2 formulas. You are responsible for learning these formulas, so I'm sure you're getting close. If you haven't already memorized them, you're close. First thing you have to do when you read the problem, and we are reading number 6, so we're figuring out if we use that one or that one. Let me number them. 1 or 2. Which formula are we using for problem number 6?
Would it be the second one?
Absolutely. It's biology. It's a population growing. It's little things growing in your petri dish. This is your formula for all natural growth. Anything from nature, anything from biology, population growth, this is your formula. So, we're starting with 193. We're ending with 391. The growth constant is 0.222, and we want to know how long it will take. So we are solving for t. Does that make sense? Everybody see where those numbers are coming from? Now, eventually, boys and girls, we're going to need logarithms, because look where our variable is. See where it is? So we're going to need logarithms, but don't start with the logarithms. What do we have to start with? What's step 1?
Divide the 190.
Exactly. And I'm not putting it in my calculator. I'm not rounding it off. I'm just leaving it as 391 over 193. We don't want to ever round off until the very end of the problem. And that's going to be true in our next unit too, when we start trigonometry. So we're just going to have to get in the habit of not having to have a decimal for everything. Okay, now I got the e by itself. So this would be the perfect time to ln both sides, right? Because when I stick an ln next to an e, it cancels. So I have ln 391 over 193 equal to 0.222t. And then to get t, I'll just divide. So ln, I hope everybody's got a calculator and you're practicing. In a minute, we're going to do some really doozy problems, so we need to be practicing on our calculator. 391 divided by 193, close parentheses, divided by 0.222. and I got 3.1803, and I'm just going to say hours. It could be minutes, it could be days, it could be years. I didn't put any unit in the problem, so you don't know, but I want you to get in the habit of putting units on your answers. So hours, minutes, days, years, whatever you want, there's a time unit on that. Any issue? Okay. All right. Number 7. Read the problem and tell me if I'm going to use the first formula here or the second formula.
The first one?
Absolutely. Guys, compounded monthly. This is your formula for compounded monthly, daily, yearly, hourly. If you're compounding anything but continuous, this one is continuous. If you are compounded any other way, it's this formula. How much will I have in my account if I deposit $555 at an interest rate of 0.035? Remember, you need a decimal. 12 years. What's my N? I am compounding monthly. So my N is?
12.
Exactly. Both places. Now I'm going to go ahead and make that exponent a 144. Do I need logarithms? No, my friends, we just type it in. So 555 parentheses 1 plus 0.035 divided by 12. Don't forget to close those parentheses and then raise it to the 144th. This is a money problem, so make sure you're rounding off to the nearest cent. $844.17. All right, got an issue, you gotta speak up, folks. Otherwise, we'll just keep rolling through. Here we go, number 8. Compounded continuously. This is the formula for any kind of continuous growth, including money. Compounded continuously. So I want to end up with $1,000. I'm starting with $890, and I'm waiting 3 years. So T is 3 and R is my unknown. Andrew, am I going to need logarithms to solve this?
No.
Yes, I do, because look where my variable is. When your variable is an exponent, you need logarithms. Okay? But I'm not going to jump in and put a logarithm in just yet. What do I need to do first? Josh Ramsey, what do I need to do first here before I jump in with my logarithms?
Divide 890.
Exactly. Now, you can do whatever you want with this. Please don't round it off, though. I'm just going to leave it like that. I'm going to go to my calculator in a second. I'm just going to leave it like that. Certainly, I could cancel out a couple zeros. Now, since I got rid of that number, there's an E sitting there all by itself. So we'll take the natural logarithm of both sides. So ln of that fraction equals 3r. So all I need to do is ln my fraction, close the parentheses, divided by 3. You can answer this a couple of different ways. One way is just to write down what's on the screen, which is 0.388. Another way is to say 3.88%. It does ask for an interest rate. Normally that's a percent, so that decimal would be 3.88%. Okay? Right now, we're going to use a couple of formulas that you are not responsible for memorizing. We're going to use these formulas. You need to know how to use them, and more importantly, you need how to actually get answers. So you need to know how to type all this mess into your calculator. I will give you the formulas, though. So all you need to do is know the difference between them. So future value means, okay, stop, let me back up. These formulas are used when you are making payments. So, when I think about the problem I just did, I walked down to the bank, I handed them $890, I came back 3 years later and I wanted to have $1,000. It was a one-time deposit. Okay? So the formulas that we have been using up to this point are one-time deposits. These two formulas are the ones we'll use when you are making payments. So I have a retirement account. Obviously, I'm getting close. I need a retirement account. I make monthly payments, or actually every 2 weeks, payments into my retirement account. So I'm going to use one of these formulas. Some of you may own a car, and you make monthly payments on your car. You're going to use one of these two formulas. These formulas are used when you are making payments. If you are making payments saving for the future, you use the future value formula. If you are making payments to pay something off, like a car payment, a mortgage payment, a Visa card payment, you use present value. So saving for the future, future value, paying something off, present value. Okay? So let's read problem number 9. Carlos purchases a new pickup truck for $18,500. What are the monthly payments? That clues me in. I'm using one of these two formulas. On a 4-year loan with a $2,000 down payment, if the annual interest rate is 2.9%. Okay? Which formula? Future value, FV, or PV, present value? Which one?
Present value.
Present value. Carlos is paying off his truck. All right, now we need to talk about what goes where in this formula. So let me write it down first of all. We're going to use our present value formula. All right, there it is. Make sure I copied it right. I do not have these formulas memorized. Okay, here we go. All right, Now, R is the amount of the payment. So in this particular problem, that is going to be my unknown because it says, what are the monthly payments? So R is the amount of the payment. PV is the present value of the loan. So what am I going to put in for PV? It's the present value of the loan. No, his loan isn't 2,000. How much money did he have to borrow?
18,700.
He actually borrowed 16,500. Okay, when you go in to buy something big that you're gonna have to borrow money on, you make a down payment. So if the car cost 18,500, but he made a down payment of $2,000, then that means he really only had to borrow 16,500. Does that make sense to everybody? Okay, that's how that works. So I know 18,500 isn't the problem, but that isn't what he borrowed. He borrowed the present value of the loan is 16,500. Now, the annual interest rate is 2.9%. When you do the I is the interest rate in this problem. These are ones. When you do the I in these formulas, it's a little bit different. You take your interest rate, which is 0.029, but you have to divide it by the number of payments in a year that he's making. So I is going to be 0.029 divided by 12. Both of the I's are 0.029 divided by 12. So you're going to make a note of that, guys. When you use these formulas, the PV and FV formulas, I is the interest rate divided by however many payments a year you're making. And then the N is the total number of payments you're going to make. So look at the problem. It's a 4-year loan. He's making monthly payments. So my N is 48. So my exponent here is negative 48. I is the interest rate divided by the number of payments per year. And N is the total number of payments made for the loan.
Wait, why would that be negative 48?
Formula, it's negative.
Oh, okay.
And 48 is 4 years times 12 payments a year. Okay, so now I got to figure out how to get an answer out of this. This is a mess. And Mrs. Ford will not allow any round off, so keep that in the back of your mind. Am I going to need logarithms? Is this going to be a logarithm problem?
Yes.
Am I solving for an exponent? Is my variable an exponent?
No.
Okay, then I'm not using logarithms. The only time you use logarithms is when your variable is an exponent. Basically, I know this is ugly, guys, but isn't this just a number? So to get R, I just have to take 16,500 and divide it by that number. I mean, it's that easy, wouldn't you agree? This is just something, and I'm just going to take 16,500 and divide it by that. So I'm going to type this in on my calculator now. So I'm going to type in the numerator exactly the way I wrote it, and I would like you to do the same, okay? So if you have your calculator today, and I hope you do, I need you typing with me. Here we go. 1 minus parentheses 1 plus 0.029 divided by 12, close parentheses, raised to the negative 48th. Did you get like 0.1094? Would someone acknowledge that's what I got? Okay,
Yeah, that's what I
good.
got.
Now, okay, well, you'll try it on the next problem. Now, that has to be divided by this. Now, so you got your decimal, just hit divided by, parentheses, 0.029 divided by 12. Because when you are dividing by more than one thing, you have to make sure it's in parentheses. So now you should have gotten 45 point something. And now we're going to take, so this is all just 45. So to get R by itself, I have to take 16.5 divided by second answer. And the amount of the payment is $364.49. All right, we're going to do the next one and we'll go through it. So if you didn't get that on your calculator, pay real close attention on the next one because it's going to be some of the same stuff. All right, at the end of each quarter, Emily makes a $500 payment into the mutual fund. If her investments earn 7.88 annual interest compounded quarterly, what will be the value of Emily's annuity in 20 years?
Is this the future?
This is going to be future value because Emily is saving for the future. She isn't paying off her truck. She's saving for the future. So, let me write down my future value formula. Now, the good news is the I's and the N's are handled the same way. The R stands for the amount of the payment. I is the interest rate. The interest rate divided by the number of payments per year, and N is the total number of payments being made. So here we go. We want to know what is the value going to be. So we're solving for FV this time. Would you agree with that? Solving for FV. What is the value going to be? Her payment amount is $500. The interest is 0.0788 divided by, now be careful, how many payments a year is she making? 4. So we're going to divide it by 4. And it's over 0.0788 divided by 4. Now the only thing I haven't put in is my N. N is the total number of payments in the problem, in the whole situation. So she's making 4 payments a year, and she's doing it for 20 years, so your exponent is 80. All right, does anybody have a question about where any of the numbers came from, first of all? Okay, now we're going to type it in then. Okay, so I'm going to do my big parentheses first, just like I did over there. I'm going to do this first. Okay, so parentheses 1 plus 0.0788 divided by 4, close parentheses, raised to the 80 minus 1 equals. So I just typed in my numerator. I'll take out this parentheses so there's no confusion. I just typed in my numerator here, right here. I typed that in. I got 3.76. Some thumbs up are coming, good, okay. Now, I need to hit divided by, because I still need to divide by this, but that's two things. So parentheses, divided by parentheses, 0.0788 divided by 4. So the value of this right here is 190 point stuff. And then this time, I'll just take it times 500. And the value of her account will be $95,000, $95,483.39. Okay, so if you didn't get that, I need you to type parentheses 1 plus 0.0788 divided by 4, close parentheses, raised to the 80th, minus 1 equals. Divided by parentheses 0.0788 divided by 4 equals times 500. And if you type that, this is what you're going to get. Oh, shoot, this is now a lunch period, isn't it? We're going to work through and then you'll go to lunch, but I got to figure out when I stop. Okay, I got it. Okay. All right, let's go on to number 11. Or is that what we're ready for? Yep, number 11. I'm going to leave both my formulas up here. Which one am I going to use for problem number 11? PV or FV?
Is it PV?
Oh, yes, it is. Guys, if you are paying off your house, if you have a loan, if you're paying off a loan, it's PV. PV is paying off a loan. If you are making payments on something you bought, then it's PV. If you are saving for your future, for your college education, for your retirement, it's FV. FV is things in the future. PV, you owe that money on that house right now. So here we go. Jendo obtains a 30-year, $86,000 house loan. So the present value is $86,000. We want to know the payment. And the interest rate is 0.0875. Remember, in these formulas, though, you have to divide your interest rate by the number of payments you're making a year. So these are going to be monthly payments, so it's going to be divided by 12. And that's what your I is in the bottom also. And then our exponent is N, is the total number of payments you're making over the course of the whole loan. So it's a 30-year loan, and I'm making 12 payments a year. So isn't my exponent negative 360? 12 times 30? All right, we'll walk through this one more time just in case there's somebody having issues. Type in your whole numerator exactly the way it's written. So type 1 minus parentheses. 1 minus parentheses. 1 plus 0.0875 divided by 12. Close the parentheses and raise to the negative 360th power. Michael, you typing? You got a calculator? You typing? Good deal. Have you got an answer yet? Okay. Anybody have an answer yet from typing in just the numerator? Just the numerator.
It's like a 0.9268.
It is 0.92. If that's what you got, if you have on your calculator 0.9268, then you typed in the numerator exactly as it was written. Now we're going to hit divided by parentheses 0.0875 divided by 12. And now you have the value of the whole bracket here, which is about 127. So this is 127. You're solving for R. You're just going to take 86,000 and divide it by second answer. And his house payments are $676.56.
I have a question.
Yep.
How did you do the second answer mechanic on the calculator?
Second answer.
Okay, thank you.
We've used that before. That's what we do when we want to use that number, but we don't want to type it all in. We just hit second answer, and it does it for us. Some of the new calculators, you can use your arrows to do that too. All right, number 12, here we go. Joelle invests $8,000 into a retirement account with a 9% interest rate compounded monthly. How long will it take this single payment to grow into $16,000? What formula am I going to use?
The future value.
Actually, I'm going to use this one. Why? What in the problem tells me that I'm going back to one of my old formulas? Single payment. Boys and girls, stop and listen to me very clearly. This is easy. If you're going to use PV or FV, you are making regular payments. You are paying off your credit card. You are paying off your house mortgage. You are putting in, every week you're setting aside $10 for your college education. These are repeated payments. You use these formulas when you're making repeated payments. If you are not making repeated payments, you do not use these formulas. Okay, so Joelle invests 8,000, so I know P is 8,000. 9% interest rate, she's pretty lucky, 9%. Compounded monthly. How long will it take her? Essentially to double her money, to end up with $16,000. Everybody good with that? All right, how do I start solving it?
Divide by 8,000.
Absolutely, we're going to divide both sides by 8,000. So that gives us 2. Equals 1 plus 0.09 divided by 12 to the 12t. If you want to clean that up, you don't have to round it off. That is a finite decimal. So if it's easier for you to think of that as 1.0075, it's fine with me. It doesn't make a single bit of difference. But it does look a little easier when it's just a plain number and not all that fraction stuff. Am I going to need logarithms to solve this?
Yeah.
Absolutely. Anytime my variable is an exponent, I'm going to need logarithms. Now, we did a few just a minute ago where we ln'd both sides. You can certainly do that, but there's no benefit this time. Nothing is going to cancel out. So I'm just going to go ahead and log both sides. Does not make a bit of difference. There's just no benefit to ln'ing this time. So I have the log of 2 equal to 12t log 1.0075. Remember, the whole purpose of taking the logarithm is so you can pull the exponent off. Now I can solve for it. I can't solve for it when it's up high. I have to bring it down. So now I'll take both sides and divide by the 12 and the log 1.0075. To get t by itself, I have to divide by the 12 and I have to divide by the log. Now compared to the last ones we did, this is going to be a cinch to type in, but remember, there's 2 things down here. So you're going to have to use parentheses. So log 2, close parentheses, divided by, parentheses, 12 log 1.0075. And it's going to take 7.73 years. How long will it take to double her money? Only 7 years. And of course it's only 7 years because that's a huge interest rate, 9%, that's huge. All right, anybody have a question about that? One more time, how's come I went back and used my old formula?
Single payment.
Exactly.
Multiple payments.
Exactly. Multiple payments. If I'm doing multiple payments, I'm PVN or FVN. Otherwise, I'm going back to the tried and true, the old formulas that we started with. All right, so let's read the next question and see, are we making payments or not? That'll be our first question. So it is this, number 13. Well, it says car loan payment. So I guess I'm making payments on my car loan. So since I'm paying off my car, since I owe money and I'm not saving for the future, I'm going to use PV. Would you agree with that? PV. Now, what is her monthly payment? So I'm finding R. For a $4,500 car loan. So she borrowed $4,500. Her interest rate is, a whopping 0.1025. She is making monthly payments. So remember, in the PV and FV formulas, I is the interest rate decimal divided by the number of payments you're making every year. And that's going to go in the bottom too. So 0.1025 over 12. Now, N is the number of payments total that she's going to make. So this is a 3-year loan, monthly payments, so my exponent's negative 36. That makes sense? All right, let's see if we can type in the numerator on our calculator. Let's just do just the numerator. We'll touch base and then go from there. Some brave soul other than Jacob or Grace Malarney, because they're my best volunteers and I love them and appreciate them so much. Somebody else, tell us what you got when you typed in just this numerator, just the top of the fraction.
0.2637.
Indeed, perfect. 0.2637, very, very good. Now, let's go ahead and do divided by parentheses the denominator. Now I need some other brave soul to tell me, what did you get now for the entire bracket? Brave soul. Perfect. Perfect. So the bracket is 30.87. Now, I am solving for R, so does it make sense to you that you're just going to take 4,500 and divide it by that number? So I'm going to do 4,500 divided by second answer. And her payments are only $145.73. Is that okay with everybody? We'll do one more. Hang with me, one more, and then you can go have lunch, okay? All right, here we go. One more. Number 14. An IRA account. Amy contributes $50 a month into the bond fund that earns this interest. What is the value of her investment after 25 years? She makes payments, $50 per month, saving toward her future. Everybody ready with this one? All right, get everything plugged in. This is the formula. We're doing problem 14. Get it all plugged in. and let's see what it looks like. Okay? All right, here we go. Let's see. When you're done, kind of take a gander up here. See if yours looks like mine. Anybody have a question? That exponent is 300. How did I get 300 for my exponent?
25 times 12.
Yep. 25 years, 12 payments a year, 300. All right, everybody good? All right, let's type it in. See what you come up with. All right, I bravely threw an answer out there. You tell me if that's what you got or if I typed it in wrong. Caleb's giving me a thumbs up. That's good. We match. Got some other thumbs up. Super-de duper. Perfect. Perfect. All right, that's good. You guys have done a great job. We'll finish this up in our next class and review. We'll review one more day after that, and then we take our test. So, great job. Make sure you're checking Power School and Schoology and getting that homework in on time. You're awesome. Have a great lunch.
Thank you.
You're welcome. You're welcome. Have a great day.
We come back this one, right?
You do not need to come back.
All right. Have a good day.
Bye. George, wake up, sweetie.